Hey there folks, welcome to Module 6 of the Microsoft MD-100 course. Today's video and module is titled Configuring Storage. So you can probably guess it's got all to do with storage. Now as for the main sections in this specific module, the first section is titled Overview of Storage Options, so a bit of an overview there. The second will be Maintaining Disks and Volumes. And the third and last section will be managing storage spaces. Now, like usual, folks, these are obviously not the only topics in this module. These three are simply the main sections. If you want a better idea of the topics in this specific module, you can, of course, just view that in the video description down below. Just go have a peek there. And you'll obviously find the usual convenient timestamps there as well. Alright, so if you guys haven't done it already, please give the video a like. If you'd like to know when the next module comes out for this course, also remember to subscribe, otherwise you might miss it. And with that out of the way, let's get on with the first main section, which was Overview of Storage Options. Alrighty then, so in this section, the first thing we'll be looking at is storage options. So basically the various ways we can go about storing our information, various ways, various locations, that kind of stuff. So the first one up is probably the most common and the most widely used one, which is local hard disk drive, or just local hard disk. So in other words, the drive inside of your laptop, your desktop, or server. That's it. Now in this section you get two subcategories, the first of which is SSD, you probably know what that stands for, solid state drive. The second one, which I find humorous, is hard disk drive. Now why I find this humorous is because it's confusing to a lot of folks, especially the people that's brand new to IT. So if you go back about 10, I actually want to say 20 years in time, we only had hard drives. So all hard drives had a little spindle in the middle, it'll spin, it uses magnets and lasers and that kinds of stuff. It's got movable parts, basically is what we're saying. And you probably heard the old saying where people would say, don't drop a drive, because you could obviously break it. Now, solid state drives do not have any movable parts. So you can actually go and drop it and it's 10 to 1 going to be fine. Now, solid state drives are solid state, hence the name. Now back then, 10, 20 years ago, we only had hard drives, those mechanical ones. We just call that the hard disk drive, the hard disk drive. So it doesn't actually have an official name besides, just calling it the hard disk drive. Now some folks like myself would just call it the mechanical drive because it's mechanical, like the name says, mechanical. It's got parts that moves around. So you can either call it the hard disk drive or you can call it the mechanical drive, but that might confuse people that's, not too clued up in IT. And then, of course, you've got the solid state drive, which is, well, the opposite of mechanical. All right, so enough talking about nonsense there. Moving on to our next type of storage, which is also a type of hard drive. This one is called a virtual hard disk drive. Now, I do want to point out, folks, that what I'm talking about here is specifically about Microsoft virtual hard drives. You get many kinds of virtual providers out there, especially when it comes to virtual machines. We are talking about Microsoft. So Microsoft-wise, it'll be things like Microsoft's Hyper-V. All right, so within Hyper-V, those virtual hard drives, so those virtual computers, they can either be VHD or VHDX. These, in case you don't know, is the file format. So if you were to go and look at what the file format is, wherever this hard drive might be stored in your computer, for this virtual computer, you're going to see it's either going to be .vhd or .vhdx. So that's the file extension. Now VHD is the older generation, which we call generation 1. VHDX is the newer generation, which we call generation 2. More on that later once we get to virtual machines. There's a whole module or a whole section about that in one of the modules where we talk about virtual machines. So for now, VHD, all you need to know, that's the old one. That's for generation 1. And obviously it's got, limitations. It's got benefits and all that. Mostly, limitations if you think about it. For now, the only thing we're going to mention is it is limited to up to 2 terabytes of storage. Can you believe it? That's a limit. That's a crazy amount of storage for a virtual hard drive, but yet it is a limit nonetheless. If you look at the newer one, VHDX, which is for generation 2, its limit is it can store up to 64 terabytes of storage. Insane, isn't it? Alright, so now besides local and virtual hard disk drives, we've got something else I need to discuss with you guys here, and that is server-based storage. I'm going to mention free in just a second, but bear in mind what I mention is what is, mentioned in the official course. I don't fully agree with this, and I won't always fully agree with it, but I'm still going to mention it nonetheless because it's in the course. If it's in the course, there's a chance it might be in the exam, which is why we need to go and cover it. You never know. It's best to cover everything and then just be safe, as they would say. Now, if I disagree with something, I'll normally point out why, which is what I'm about to go and do. So server-based storage, the first one is file server, normal traditional file server. That one I do agree with. You'll find that most companies will refer to this as the DFS file server. File server, just DFS. I think it stands for domain file server or something like that. The second one, which I do not fully agree with in this category, is NAS. So this is an abbreviation. It's short for Network Attached Storage. It's literally the device you just hook up to a power cable, a network cable, and you can pretty much just go and jump in and use it. Obviously, it's a little bit more than that, but we'll get to that in the next slide or two. Then we get SAN, a SAN. So the middle one there was NAS. The third one and the last one in this section is SAN, which is also an abbreviation. It's short for Storage Area Network. So now that one I kind of sort of agree with because it is storage, it is server storage to a certain extent. So it can actually fall into more than one category. Storage area network falls into server storage, which is what this section is all about. It also falls into network storage, which is not a category that's even listed here in the course. So we are going to talk about network and cloud storage as well in case you guys are curious. It's not officially per se in the course, but I am going to mention it as an extra just in case it might be an exam. So storage area network being SAN can fall into server storage. It can fall into network storage. Now the middle one there, NAS, I don't fully agree with that being server storage because it's not actually a server. It's just a device which has got hard drives in it, and it's normally seen as network storage. I mean, it's in name, for crying out loud. Alright folks, before we hop on over to the next topic, just to help you better understand NAS and SAN, since those two topics can be somewhat overwhelming to folks new to them, let me start off by actually showing you what a NAS looks like. So I've already mentioned earlier that this is a network device that has drives in it. These devices are normally used mainly for storage purposes, although you can actually use them for other nonsense too if you really feel like that. And if you go check on some of the websites for some of these brands, you'll find that they sometimes even market these as media entertainment systems, where you can literally go and hide it behind your TV and put your movies and series on there if you're really crazy like that. Not what they were designed for, I think, but I've seen people do it. Anyway, now regarding what one actually looks like, you need to be aware that you get many brands of this device. And you also get them in many form factors. So different brands, different form factors. So my NAS drive might not look the same as yours, might not look the same as the next guy, and so on and so forth. So with that in mind, here is a picture of a totally random brand. And no, I'm not promoting this brand, nor are they sponsoring me or my channel anyway. It just happens to be one of the brands I worked most commonly and most often with. So this brand is called QNAP. If you're curious, you can go run a search for them in Google and just go check out a few random pictures in Google. You don't have to go to any website. Literally just go to Google, type in QNAP, and go to images, and then there you'll see all kinds of examples of, some random NAS drives, in case you're curious. So in your environments, though, it could be many other brands, not just this QNAP. Now the picture you see in front of you is only one of the many form factors a NAS drive actually comes in. This form factor is a flat one, and this actually allows us to slide this bad boy into a server rack, for those of you that know what a server rack is or what a rack is in general. So if you go to server rooms, you'll find they've got these tall cabinets, and they've got lots of these little slots that you can basically slot servers and stuff into, and you can actually go and slot one of these little NAS drives into one of those slots if you so desire, and if you want to actually have it in your server room. Another form factor you get is, for example, this one. Now this one, you'll notice, is a very square one in dimensions. You can actually find these in different colors too if you really want. I mean, the most common colors I've seen is normally black and white, but I suppose theoretically speaking there might be other ones out there, although I've never seen them. I've only seen black and white ones. I think those are pretty standard colors for IT equipment. So the square ones are roughly the shape and size of a small car battery, just to give you a bit of sense of scale here. It's obviously not nearly as heavy as a car battery though, so thank God for that. Now, most of these NAS drives do not actually come with the hard drives included. I think this might actually be all of them. You normally need to go and buy those separately. Kind of sounds like when you go buy a toy for your kids and they tell you the batteries are sold separately. Always frustrates the daylights out of me. So when you go and buy yourself a NAS drive for yourself or a client, you're probably going to have to go and buy a hard drive separately. And if you're wondering what kind of hard drives to get, because some people are probably wondering, okay, what kind of hard drives do I have to get? They take normal desktop hard drives. So they've got bays, and you're going to have to open one of these bays, assuming the device has been turned off, of course. And you're going to go put a hard drive in there, and you're going to have to go through the excruciating process of screwing them in a lot of these NAS drives. Not all of them, but most of the ones I've worked with, you've actually got to go and screw them in old school. It's a bit of a frustration, but it is what it is now. Now, something else you guys will notice, whether these be flat NAS drives, square NAS drives, potato, doesn't matter, is they always tend to come in even numbers. So the numbers are the bays I'm talking about. So if you go look at the bays on a NAS drive, you'll find they come in 2 bay, 4 bay, 8 bay, 16 bay, and of course the list goes on. Now, I'm not sure if you guys have noticed that, but there's a very good reason behind that. The reason they've got even numbers of bays is because of the redundancy that's embedded into these devices. Most of these devices use something called RAID, most commonly RAID 1, which means mirroring, or more specifically, cloning. So when I have, for example, a 2 bay, let's use it as 2 bay as a small example. If I have a small 2 bay NAS drive, which is the smallest one you can get, it can obviously take 2 hard drives. But just because it can take 2 hard drives does not actually mean you have more space now. It simply means you have redundancy. Whatever's on the first hard drive is now going to get replicated to the second hard drive. Some of you guys might notice cloning. Some of you guys might notice as mirroring. In a nutshell, what's on the first drive is what's going to be on the second drive. So if my first drive is a 1 terabyte and the second drive is a 1 terabyte, that doesn't mean I've got 2 terabytes. You still have 1 terabyte. It is simply replicated / cloned / mirrored to the second drive. This gives you what we call redundancy. Some folks call this fault tolerance. But what it means is, should one of those drives fail, God forbid, hopefully that never happens, then you are not going to find yourself in a pickle jam, because you can simply just go and use the data on the remaining drive. All you need to do is just remove the failed drive, get a new blank one, slide it in, and replication will start occurring again. It's going to start cloning itself to the new blank drive again. Easy peasy. Now, how long exactly it takes to go and clone, I cannot tell you the exact number, but I can give you an estimate based on what I've seen. Obviously, this varies from brand to brand, model to model, device to device, but it roughly takes about a day and a half per terabyte, based on my experience. So if you've got a 2 terabyte drive that needs to replicate to another 2 terabyte drive, and let's assume this is a full 2 terabyte drive, you can expect this to take about approximately 3 days, a day and a half per terabyte. So if it's a 1 terabyte, it's a day and a half. 2 terabytes, 3 days. If it's 3 terabytes, 4.5 days. If it's 4 terabytes, you can expect this to take up to 6 days. So this is not set in stone. Could be quicker, could take longer. So don't take my word for it. That's only what I've observed from experience. I'm talking from experience now. Now, if you do find yourself in a sticky situation where you end up having to replace one of these drives, or you just want to go and put in multiple drives, I am going to recommend you try and keep it to the same size. And I am going to recommend you try and keep it to the same brand. Now, keeping it to the same size is not, a train smash. This is just to avoid wasting space. So if you've got a 1 terabyte drive in there, and you're going to go put a 1.5 terabyte in there that's blank, you're going to be wasting a whole half a terabyte. Why? That's a waste of money. It's a waste of space. So just for the purposes of not wasting space, you're going to want to go and do that. Now you might wonder, but why the heck do you need to use the same brand? That's not something official you'll find in any course. The only people that's going to tell you this is people actually in the field. If you're going to go and mix hardware, and I'm not just talking about these drives, this applies to pretty much anything, servers, RAM chips, network cards, you name it. If you start mixing brands, you're going to get the weirdest, unexplainable glitches and bugs and errors. Things you cannot explain to someone, you'll never see it anywhere else. So what brand you need to use, it doesn't matter. You can honest to God use any brand you desire. Just stick to the same brand. So if you currently already have a certain brand of drives in your NAS drive, you're going to have to go and check first, okay, what kind of drive brand is this? You're going to have to go and open it up, check it out. And if you see, okay, it's drive brand X, let's just call this X. Then go and buy some more of that brand called X and just slot those in there, just to avoid any potential issues going forward. Okay, so just to summarize, so to speak, here is a small, tiny little network. I basically thumbsuck this. And in this network, you have a NAS drive, as you guys can see there at the top in the middle. And on a network, you will obviously have servers. I only have one there in this picture, but realistically, there could be more than one. I have a computer in this little picture of mine, but realistically, it could be multiple desktops, multiple laptops. I think the picture still serves its purpose. I was honestly too lazy to go and put many servers and too many computers in this picture. It's going to take me forever. I mean, the slides are already taking forever to make. So forgive me for taking the shortcut. Anyway, so when you have a NAS drive on your network, all computers, desktops, laptops, and even all servers can access that NAS drive over the network. And if you're wondering how the heck you access this over the network, it's exactly the same way you would normally go and access most other devices. You're going to go and start in by typing in whack whack. I suppose you guys might know it more commonly as backslash backslash. So you can go to Cortana or your search bar, you type in backslash backslash or whack whack, and you type in the NAS drive's name or its IP address, and boopity bop, there you go, Bob's your uncle. You will connect to it exactly like a PC or a server, and for the most part, you will not even know it's a NAS drive. I mean, heck, you can even go and map this thing as a map drive if you want to. It's going to look like a normal map drive on your computer, and you would never even know it's a NAS drive. I've done that for many clients, and they never knew it was a NAS drive. I mean, okay, well, granted, these people didn't even know what a map drive was. They thought it was just an additional hard drive, so that's maybe not the best example. But yeah, people will not even know it's a NAS drive. Okay, folks, so inclusion here. What is a NAS drive? It's a storage device. Well, network attached storage device, that is, which is used for storing, guess what? Data. It doesn't really do anything else besides storing data. I mean, yeah, it's got RAID on a device, which means it replicates your data between the drives for redundancy purposes. But other than that, it's just storage for your data. These devices are mostly used in homes or possibly in a small office environment. I suppose you guys will probably call those SOHOs, small office, home office environments. So, but generally, if you go look at larger companies, medium to large organizations, they don't really use NAS drives as much. I mean, you'd find them, but very rarely. Instead, those kinds of companies, they tend to use other forms of storage. For example, the SAN we spoke of earlier, which stands for Storage Area Network. That is something you're more than likely to see at a bigger company, not just any big company, because it is very, very expensive to go and implement that. Now, speaking of SAN, that brings me to my next small picture demo thingy, whatever we want to go and call this. Here we go. So here we have a very small but yet simple layout of a SAN network. I want to point out though that in many cases it will not be nearly as simple and nearly as easy as this diagram we've got in front of us. This really is pretty much almost as simple and as easy as it gets. Now, SAN or Storage Area Network is a special high-speed network that stores and provides access to large amounts of data. This is going to be for larger companies, obviously. It's basically a dedicated network that is used for data storage, and this network consists of multiple disk arrays, which you guys will see there in the picture, switches, which you'll see in the picture, and servers, which you'll see in the picture. Obviously, the amount in my picture can obviously differ in real life. It could be much, much more, but generally you need at least 2 switches, at least 2 disk arrays, and at least 2 servers, for this to be classified as a SAN. You can go and add many, many more if you want to. In a SAN, we have more than one of each device, usually 2 at a minimum. The fact that we have 2 or more of every device gives us fault tolerance, something we spoke of earlier in this video. We have multiple disk arrays, multiple switches, multiple servers, and the list goes on and on. In these storage networks, we usually tend to have full redundancy. So if anything fails, nothing is actually offline. Everything is still accessible and everything should generally still work. At least that's the idea here. If anyone is wondering about the multiple servers on a SAN network, they are identical twins of one another. So you would normally have obviously no less than two. You would have preferably more than two. But beggars can be choosers. These things are very, very expensive. So you might have the minimum, which is two. Now, when you have two or more, they are identical copies of one another for obvious reasons: redundancy and fault tolerance. So when a server or a computer accesses data stored on a SAN, it is accessed as if it's a local hard disk drive. So your servers, your computers, and what have you that's accessing the SAN, they won't actually know that they're accessing a SAN. So they're going to be accessing it, they just won't actually know they're accessing it. Only you would know if someone told you or if someone showed you. They will just access it exactly like they would access a local hard disk that is physically inside the server or physically inside the PC. Pretty interesting, right? So basically, when you take your laptop, your desktop, your server, and you go and browse and you go have a look at the hard drive or hard drives, if you've got more than one installed on your PC, exactly the way they would look there and exactly the way you would access them there, that's exactly how a SAN would behave when your PC or your server accesses that storage. Your computer wouldn't know it's a SAN that it's being accessed. It's going to treat it as if it's a locally installed drive. So the operating systems recognize a SAN drive as a locally installed hard disk drive. And with regards to a NAS, which we spoke of earlier, those will be recognized as a shared network drive. These SAN networks are highly scalable. Now, for the folks that don't know what the word scalable means, that means you can upgrade or degrade these environments or components or objects, whatever it might be. And normally we obviously upgrade. Why would you go and downgrade? Obviously, we're going to go and upgrade. So when we say a SAN is highly scalable, we mean we can very quickly and very easily add additional disk arrays and storage as needed. So if I find myself in a situation where I think I'm running out of space, no big deal. I can just go and upgrade the space or the storage on a SAN. Now, I make it sound pretty easy. I mean, it sounds pretty straightforward, but in reality, it's actually insanely expensive to go and do that. So there's a difference between book knowledge, which is what we're doing now, and reality. And once you guys eventually one day go and do this, whether this be tomorrow or in 10 years from now, you'll very quickly realize there's a huge difference between theory and reality. And reality is this is very expensive to actually go and do. Okay, then I think that's enough about the storage options topic. Let's talk a bit about dynamic disks. Dynamic disks provide features that basic disks do not. You can, for example, create volumes that span multiple disks and fault-tolerant volumes. Dynamic disks can also use the MBR or GPT partition styles, something you guys might not have known about. And dynamic disks use a database to track information about volumes on dynamic disks in the computer. Each dynamic disk in a computer stores a replica of the dynamic disk database, which is useful if you experience a corrupted dynamic disk database. Windows can repair the corrupted dynamic disk by using the database on another dynamic disk. Yeah. The partition style of the disk obviously determines the location of this database. So if we go have a peek on MBR partitions, Windows stores the database in the last 1 megabyte of the disk. On GPT partitions, the database is, well, the location of it is going to be in a 1 megabyte reserved and hidden partition. I think this is something I even have on my PC. I should just go and double check, but I could have sworn I saw that the other day. Okay, and then folks, there is some things you need to be aware of course, and the following operations I'm about to list for you can only be performed on a dynamic disk. So the first operation only achievable on a dynamic disk is to create or delete a spanned, striped, or mirrored volume. Only achievable on a dynamic disk. Something else is to extend a simple volume to a non-contiguous space or span volume. Maybe remove a mirror from a mirrored volume. repair mirrored volumes, reactivate a missing or offline disk, and yeah, just be aware of these operations, I guess. So if you find yourself in a situation one day where you'd like to perform one of these, just remember they're only possible on dynamic disks. So don't go trying this on something else. Now, since we're talking so much about disks, let's have a look at some of the tools to our disposal for managing disks. When it comes to disk management tools, the ones I'm about to mention to you folks are strictly Microsoft tools. You need to be aware though that there are many other tools out there in the real world, which I suppose you can call these non-Microsoft or third-party tools. So in the real world, we use all kinds of tools to go manage our disks, not just these Microsoft tools and methods that I'm about to mention. All right, so what are these Microsoft Disk Management tools, you might ask? I'm going to list three for you folks. The first one is probably the most obvious and probably also the most well known, and that is the good old fashioned tool called Disk Management. Yeah, the actual name of this tool is Disk Management. Go figure, right? Now, some of you might call this a snap-in if you're familiar with it, but I think that really depends on how you intend on accessing it. Like most Microsoft tools, you can access this tool probably via 10 or 20 different ways. So if you're maybe going to go and access this bad boy via something like the Microsoft's Management Console, in other words, MMC for short, then yes, you'll have to add it as a snap-in. But if you intend on accessing this via one of the other 10 or 20 different ways, then it's probably just going to be a tool, a disk management tool. Now, out of the three tools I'm going to list for you folks, this is the only one of them that has a GUI. GUI. That is short for Graphical User Interface, for the folks that's not familiar with that term. It basically means you have a nice user-friendly interface you can interact with that has icons and buttons and that kinds of stuff. Very user-friendly. So let me show you folks a picture example of this tool. So that, folks, is what you can expect to see if you open this tool. And I'm actually a lazy person. The quickest and easiest way to open this bad boy is literally just to go and right click on the start button. And this works on both Windows 10 and Windows 11, mind you. Right click on the start button and you'll see a whole list of options there. One of which is disk management. That's actually going to open this window you guys see in front of you right now. Alright, so let me move that out of the way, otherwise it's going to be in the way. So, this disk management tool allows you, or the user, to do things like manage disks and volumes, and it also allows for simple partition creation. The second tool I'd like to list for you folks is diskpart. This is a scriptable command line or command line, depending on which country you're from, you might pronounce that differently. So command line tool, which is somewhat confusing for folks who have never really worked with command prompt. I'm sure by now most of you guys are aware what command prompt or CMD as some people call it. You're aware of what it is. Now in this command line interface you can do many things for the folks that are not familiar with it. Nearly anything pretty much. There are also lots of built-in tools in this command line interface, and this diskpart tool that I just listed for you folks, that is just one out of many tools. Here, let me show you guys a picture. In this picture, you can see the user went into command prompt and they typed diskpart. What you type after that is up to you or up to the user, but in most cases, it's probably going to end up being something like list disk, which is going to list all the disks on that machine which you're on. That tends to be the first command that you or most users will go and run because it allows you or the user to see what you're dealing with. What is on this machine? How many disks are on this machine? Under what number are they listed? So from there, you can now go and speculate and plan and decide what you're going to do. What's going to be your next move, so to say. Anyway, let me move this pic a bit out of the way like I did earlier. So this diskpart tool can do many things. Some of which are things like create scripts to automate disk-related tasks. This tool also always runs locally, so just take note of that too in case you didn't know of that. And then folks, the third disk management tool. You might have guessed it already what it might be, and that is Windows PowerShell. PowerShell is much like command prompt in some ways. It's still a command line interface, except this is usually blue in most cases. Not limited to that, by the way. It actually does, ironically, accept command prompt commands, mind you. So if you want, you could actually go into PowerShell and type command prompt commands like diskpart, and that's actually going to allow you to go and access the diskpart tool via PowerShell. That's also pretty cool, isn't it? Kind of funny if you think about it. Now, with PowerShell, this tool has native disk management commands, which some might not even be aware of that actually existed. It can also be used to script disk-related tasks if need be. The possibilities of this bad boy is virtually limitless. Wow, I sound like I'm selling you guys something if I say it like that. Anyway, let's move on to the next topic, which is simple volumes. So simple volumes are the most commonly used disk arrangement, something you probably knew already. This volume is a contiguous, unallocated area of a physical hard disk that you format to create a file system. Sounds fancy, but it's actually very simple. You then assign a letter to it or mount it in an existing volume by using a volume mount point. A simple volume is a volume that encompasses available free space from a single, basic, or dynamic hard disk drive. A simple volume can consist of a single region on a disk or multiple regions of the same disk that link together. A drawback about simple volumes is that they are not fault tolerant. So that means a disk failure leads to volume failure. Obvious. If you folks look at the picture example I have up for you, there are some examples of simple volumes. Here at the top, we have a normal setup of one physical hard drive that has been partitioned into two partitions. You can think of it as a pizza or a pie that's been sliced into two slices. The first one we can see is blue, and that is formatted. The second is black and says unallocated, so it's currently not in use. And it's also not going to be listed if you go browse this PC. So this setup is a simple volume that encompasses available free space from a single, basic, or dynamic hard disk drive. If you have a look at the middle setup I have here for you folks, you'll notice if you pay close attention that the space on both those blocks have actually changed in comparison to what we saw earlier in the little setup above, that little block way at the top. Ever so slightly it has changed. The black block has ever so slightly less space, which is technically free unused space. That's what the unallocated space is. And the blue block on the left is ever so slightly larger. So how this is achieved is all the user actually has to go and do is literally just right click on the blue block if they find themselves in a situation of running out of space. They will then see a drop down list. So if you go and right click on that blue block, it pops up with a little drop down list. And one of the options you're going to see in that drop down list is an option listed as extend. It says extend. Now, if you were to go and click on that extend option, it actually allows you to take some of the black, unallocated, unused space and add it to the drive that you originally right clicked on. Now, something you'll probably also notice is that extend option, even though it's always listed, is not always available. So if you go and right click on a block, you're going to find the drop down list is always going to drop down, and extend is always going to be an option, but you're not always going to be able to click on extend. Sometimes the button's going to be grayed out. It's going to be like it's disabled. And that depends on whether there's actually any free space available on that drive. Just because there's free space doesn't mean you can go and add it to that drive. That will be a span drive, something we're still getting to. Excuse me, I've got a bit of a hiccup or something. But if it's space that's free, that's on the same drive, you can go and right click on the blue block, say extend, and then take basically some of that free space and just add it to that partition. But if you have no free space on that same drive, then the extend option is usually not available. Doesn't mean you can't go and add space. I mean, if you're going to go and add space and it's not going to be that option, it's going to be something else like a span drive. Something like I said, we're still getting to. That's actually literally going to be the next topic. Now, if you folks look at the bottom section, the last section there, way at the bottom, if extending into non-contiguous space, the disk will be converted to dynamic if it is a basic disk. Just watch out for that. Okay, so yeah, that's pretty much simple volumes, folks. Let's have a bit of a look at mirrored, spanned, and striped volumes. I'm not gonna lie to you guys, this is somewhat of a complicated topic for people that's brand new to this. So if you look at that picture, it probably looks very overwhelming, looks very confusing. But I think if you just take the time to sit down with a nice cup of coffee and you chillax, relax, then you'll realize it's actually not that complicated at all. If you look at the picture in front of you, you will find that there are three disks. This is now obviously in disk management. So if someone were to go and open disk management, it's going to look something like this. So in disk management or whatever tool you're going to be using, you can see there's three disks there, disk 2, disk 3, and disk 4. Now let's start at the beginning with mirrored volumes. You'll find that way there on the left on disk 2 and disk 3, we've got two red blocks. You can ignore the color there. We're just paying attention to the fact that they're both mirrored. Now mirrored uses RAID 1 for the folks that knows what RAID is and that knows what RAID 1 is. RAID 1 is to go and make an exact replica of something, a duplicate, a clone. So whatever I've got there on disk 2 in that section which looks like it's 9,77 gigs, whatever is in that section is duplicated, cloned onto disk 3. It's an exact replica. So when you do that, if you find yourself needing to do that, it's not going to give you more space by adding an exact replica on disk 3. It is in fact going to give you something called redundancy. It's going to give you fault tolerance. So if you cannot afford to lose that data, let's say it's something very, very important, you absolutely cannot afford to lose that data, then you want redundancy. You want fault tolerance. There's many ways you can achieve that. One way is to go and mirror that volume. So if you've got two physical hard drives in your PC, you can simply just go and take that data that's very important to you and make that mirrored. Mirror that onto one of your other hard drives. It doesn't have to be the whole hard drive you mirror, you just mirror that section. So that could be a partition of your drive. In this case, we can see it's a small, let's call it the 10 gig partition. It's a small 10 gigabytes partition that's very important to you, and you decided to go make an exact replica of that onto a different hard drive. So in the event of that hard drive failing and then you obviously losing that partition along with it, you're not going to lose the data because you've got an exact replica on a different drive. So let's move on to the next one, span. So that's the purple ones in this diagram or this example for us. Now span, you'll notice, is not the exact same size. With mirrors, they were the exact same size because they're exact replicas. Spanned volumes is to give you more space. And you can do this by stretching your contents out over multiple drives. It's only achievable, obviously, if you've got multiple drives. I think pretty much all of these are only achievable if you've got multiple drives. So with span volumes, you need to have at least a minimum of 2 drives to be able to pull this stunt. Obvious, right? But there is a limit as to how many you can go and span over, and I think that limit is 32 if memory serves. I stand to be corrected. If you guys want, if it's changed, you can correct me in the comments. Let me know, because I'm not a genius. I don't know everything. If anyone in IT ever tells you they know everything, they are lying to you. There is no such thing, and that includes myself. If I tell you I know everything, I'm lying. There's no such thing. IT is simply too vast and it's changing too rapidly. The last time I checked, you can span over up to 32 volumes, 32 hard drives. So now if you go check, if you go pay close attention to those purple blocks, looking at the top one there, it's 1.95, middle is 146, and the bottom one is 3.91. So why I'm obviously trying to draw your attention to those sizes, the actual sizes themselves doesn't matter. I just want you guys to pay attention to the fact that they're not the same size. So if I had only one partition there on disk 2, which was 195, and I found myself, boys, I need more space, I can then go and span over to another hard drive. It's not like the red one where it's the same data. No, it's simply a matter of I've got more space. I needed more space, And I found myself in a sticky situation where I've already partitioned that drive of mine and I don't have enough space. Or, okay, but I think these drives we've got here is obviously an extreme exception. Normally, you won't go and have mirrored, spanned, and striped on the same hard drive. I mean, it's possible, but that's not something you would do. Normally, the whole hard drive will be spanned. So if I have disk 2, and let's imagine for a moment that whole disk 2 was purple. The whole disk 2 was a span drive. Or even before it was a span drive, maybe it is a 32 gig hard drive. If I look there at disk 2 on the left, it says it's a 32 gig hard drive. It's a 32 gig disk. And I found myself in a sticky situation where I realized I don't have enough space anymore. I can actually go and expand that into other hard drives or over other hard drives. So I can now go and add disk 3 to the disk 2. Wow, to disk 2, that's a mouthful. And that's now going to make it a 64 gig drive. It's going to look and appear as if it's one hard drive of 64 gigs. Interesting, right? And you can do this up to 52 times. Obviously, the bigger the hard drives, the bigger space you're going to have. So this makes it very easy to just keep adding and adding and adding space, and that makes your planning also a dream. So it doesn't give you redundancy. It does not give you performance. It simply gives you more space if you found yourself in a sticky situation where you need more space. This is something you'll find that we do on servers. We don't really do this on desktop or laptop PCs. Now, striped volumes. That's the bluish kind of color one there on the right. Now, like the red one, you'll notice that the sizes are exactly the same. Now, the red one, mirrored, uses RAID 1. Striped uses RAID 0. RAID 1 is for redundancy and fault tolerance. It's an exact clone. RAID 0, for the folks familiar with RAID, is for performance. Does not give you fault tolerance, does not give you redundancy. It is for performance. So what's going to happen there is obviously you need 2 drives or more. And I wouldn't say it's an exact replica like what we had with a mirrored volume. Instead, your data is split across multiple drives, 2 or more drives. Now, I'm not sure if you guys are aware of this, but the hard drive generally tends to be the slowest component in your computer. So if that's the slowest component in your computer, especially if this is something like a gaming computer or a server, then that's basically causing bottlenecks. So what if I told you can go and increase the speed of your hard drive? And no, we're not talking about solid state drives or something like that. In the old days, we used to use striped volumes quite a lot. Way before solid state drives came out, this used to be a thing. We gamers used to go and stripe our drives. I kid you not. You needed a fancy motherboard. It cost you an arm and a leg. And we would go and stripe our hard drives because this would cause bottleneck. We had fast CPUs, lots of RAM, great graphics cards, but then we would still be stuck with these slow hard drives that could only feed the information so fast to the RAM and the CPU. So what we did, and you don't have to do this, luckily you guys have got solid state drives these days. What we did back in the day is we would take 2 or more drives, stripe them, which basically splits the information over 2 or more drives. So you're kind of sort of doubling and tripling the speed. So if I've got 2 drives and I split the information over 2 drives at the same time, half, you could say the top one is A, the bottom one is B, and the top one is C, and the bottom one is D, and the top one's E, and the bottom one's F. It gets split like that. It's effectively going to kind of sort of double the speed, so to speak. And you can go and give the information to the CPU and the RAM and all that so much quicker. It increases your I/O speeds. So if you're very frustrated by the I/O speeds, information and output, the input and output of your hard drives, you can go and speed it up by doing something like that. Now the black on the right, I'm not going to discuss that because we did that on the previous slide. That's just unused space, obviously. That's unallocated. Up until Windows XP, for the folks that worked up until XP, that used to be listed as RAW. Capital R, capital A, capital W. RAW. Now it says unallocated, which sounds a little bit more professional if you think about it. Anyway, folks, let's move on to the second main section in this module, second of 3, which is maintaining disks and volumes. Now, right before we jump into this stuff, I do want to point out that I am going to discuss a few topics that's not actually applicable in real life anymore. For example, at some point, we're going to talk about, defragmentation. At least that's another word for it. And that is something you need to know for the course. It is something you need to know if you intend on writing this exam. Well, there's 2 exams, that is. But in real life, you don't actually need to know that anymore because Windows actually does that automatically. Anyway, more on that once we get to it. So the first topic in this second main section is monitoring storage usage. Now this is, I wouldn't say it's useless for yourself because there is times when I found when my PC would be slow or where I would have a lot of space being used on my computer, and for the life of me, I cannot account for some of it. Maybe I've got a 500 gigs hard drive. I think the other day I had a terabyte hard drive, and I could go and account for about 500 gigs of that terabytes. The other 500 gigs, I had absolutely no idea where it went. I went and checked everywhere. I checked my videos, I checked my musics, I checked my programs, my games, and for the life of me, I had no idea where it was going to. So at some point I had a hunch it might be my temporary folder. And you know what I went and did? I went and checked in the storage option, which is now available on Windows 10 and 11. We'll show it to you practically in just a second on both of these operating systems. And if you go into the storage options, there you can go and see exactly where your storage is going to what programs, to which folders, all of that. Now we have a picture in the slideshow right now, but please don't pay too much attention to that. I'm going to show it to you guys practically because it probably looks different now. And when I show it to you guys practically on both Windows 10 as well as Windows 11, please take that with a pinch of salt as well, depending on when you're watching this. If you're watching this very, let's say just right after I uploaded the video, then it should probably still be the same, depending on your build of Windows 10 and your build of Windows 11. But if you're only going to watch this specific module or the specific lesson a few months or even a year or more after I've uploaded it, the concept should still be valid and you should still be able to pass the exam, watching this. But just bear in mind, Microsoft does have a tendency of moving things around cosmetically. They'll maybe change the way the buttons look and where the buttons actually are located, but the theory still stays the same. Anyway, so let's show you guys where you find this. I'm going to first show you guys on Windows 10. So I've got a Windows 10 and a Windows 11 machine idling in the background. Let's switch over to my Windows 10 machine.
A few moments later.
Alright folks, here we are on a virtual machine with Windows 10. It's idling here in the background. So I'm going to go ahead and click here on the start button, bottom left. There's the little settings icon. So this is actually better known as the settings app, effectively the new control panel for Windows 10. So we're not going to go into the old control panel. We're going to go into the new one, the settings app. I'm going to go click on that little bugger. And here we go. So what you see here might also vary. It depends on what edition of Windows you're running. Are you running Enterprise, Professional, or something, lower ranking? And even if you are running the same edition as me, I'm not even sure what I'm running right now. I think it's Enterprise or Professional. It doesn't mean you'll see the same tabs as me. It depends on what build you're running and when you're running this. Like we just said, Microsoft loves changing things. So we're trying to view storage of this machine. Storage is something system related. So we can probably expect to find that here under System. So I'm going to go here to System. You got to love how Microsoft organizes this. And on Windows 11, it's the same principle. The menu is going to look completely different, but it's the same principle we'll follow. So on the left here, what are we looking for? Storage. Check it out. I'm going to go there to Storage. And right off the bat, it kind of shows you already, how much space you're using. But we could have actually seen already by just going to Explorer. I wanted to say Exploring. Go to Explorer and you can just go click on this PC and there you'll probably see your hard drives and how much space you're using. So that's not what we're too interested in. We are interested in seeing where our space are actually going to and what is utilizing our space. So you can see here there's a button here at the bottom. It says view storage usage on other drives. We'll click on that in just a moment. But I want to draw your attention to this section here. This is what it looks like at this point in time at the making of this video. Might look different by the time you guys go and check it out. But I do encourage you to go and look in your settings app. Somewhere there should be something called storage. It might not be exactly where I'm showing it is right now by the time you watch this. But somewhere you should find more or less the same concept. And if I go click there where it says show more categories, check it out. Now at the moment this is a blank PC, but in general you'd be able to see where your space is going to. Pretty neat, right? I find that very useful. In my case, all of that space that was missing was going here to temporary files. And if memory serves, I'm not sure if this machine will do it because I did it on a different build, a much older build. Let me just see if I click on that. Ah, look at that. And if you click on that, you can actually go and choose if there's something you would like to go and delete there. Check that out. Remove files. That is very useful. And that's what I used. So I went and said, I don't even know which one I did. I just know I deleted entry temporary file. So I think that's the main one I deleted, was that one. I'll just have to go and double check it. But you can go and decide, what's applicable to your unique situation or your client's unique situation, and just go and delete that, and you're going to free up a heck of a lot of space by just doing so. Let's go back a little bit further. Let's go back a little bit further. Oh, I might have gone back too far. System, storage, and let's go back all the down here. View storage usage on other drives. Now, it's unlikely you're going to do this on other drives. It's honestly most of the time just going to be on drive C where your space is missing. But if you find yourself in a weird situation where you want to know what's going on in other drives, you can just go click there. Click there. There's a secondary drive. You might have third ones, fourth ones, fifth ones. I'm going to go click on that one. And it's basically the same principle as you guys can see. So with that in mind, let's switch over to Windows 11 so you guys can see it's still very much the same concept. So switching over.
A few moments later.
Right, folks, here we are on Windows 11. I apologize for the white bar at the bottom. It's because I'm running Windows 11 on a virtual machine. And as you know, virtual machines don't exactly have fancy graphics cards and things like that. So, with that said, I'm going to click here on Start, which is now in the middle, not in the bottom left anymore for the folks that's not familiar. I'm going to click on that. I'm going to go to Settings, in other words, the new control panel, Settings app. And I believe I have shown this before on this course, just on a different module. Looks somewhat different. Now, obviously, if you've got the right graphics drivers and a graphics driver, a graphics card and all that, this menu will be transparent. Windows really went out of their way, or Microsoft really went out of their way to give the looks and the feeling of Windows 11 in an overall. It looks very, very cool. Not this white that I'm seeing right now. Anyway, so what are we looking for? Storage. Check it out. I mean, how easy was that? You cannot miss that. Now click on storage, and right off the bat you're going to see it looks very familiar than what we just saw on Windows 10, isn't it? Just give it a moment. It's still busy doing its thing here. So I can go and check it out. I can go say view more by categories if need be, and that gives me a very much the same sense and feeling of what I just saw there now, doesn't it? Let me see. I'm probably going to go back too far. No, I'm not. Also, various other options you can go and play with. Not something we're going to discuss right now. I'm just going to click there just to give you guys an overview of what you can see there. Check it out. Whole bunch of other things you can go and play with. So that, folks, is where and how you can go and view where your storage is ultimately going to on Windows 10 and Windows 11. That brings us to our next topic, which is disk optimization. So this is the defragmentation and fragmentation I mentioned just when we started with section 2. Now, yes, I know the title says disk optimization, but that includes fragmentation and defragmentation. So let's start at the beginning. What is fragmentation? So you can think of this as your workspace. Imagine you've got a desk in front of you, and on this desk you've maybe got your desktop or your laptop PC. You've got a bunch of papers and pretty much whatever you would expect the average person to have on their desk. So maybe in the morning when it's bright and early, your desk is nice and neat and very well organized. And as the day progresses and as you start working, the desk gets messy and disorganized. So at some point, maybe around lunchtime, someone comes to your desk and this person asks you for a certain document. And now I wouldn't say this document is missing, but it's going to take you some time to find this document. Let's imagine it's a physical piece of paper, for argument's sake. So you're going to dig and dig and dig and dig through your stacks of papers, and eventually you'll find this paper or this document, and you'll give the person what they're looking for. Now, if they would have came to you in the morning, bright and early, when your desk was very organized, what do you think would have happened then? Would you have found the document? Yes, you still would have found it, except the difference is you would have found it so much quicker. So fragmentation, in a nutshell, is when your desk gets messy. Does that mean anything is missing on your desk? Absolutely not. Everything that was there is still there. It's simply messy and unorganized. Now, with a hard drive, the same thing happens. In the beginning, when you just installed Windows and you just installed your programs and dumped some data on there, everything is very neatly organized. And as time goes by, you obviously uninstall programs, install some new ones, you remove documents, videos, pictures, and games, and all kinds of stuff. You add some new stuff, you move stuff around on the drive, and all of this causes your hard drive to become what we call fragmented. In other words, messy. So that brings us to our next topic. What is defragmentation? So that is when you go and take the time to go and clean up that desk of yours and, basically reorganize your papers and all that. So that if someone comes and asks you for something, you're going to find it so much quicker because you're going to have a very good idea of where it actually is. Now, with that whole thing in mind, I want you guys to have the picture in mind. I think what's going to make it easy is if I actually give you guys a picture. So just give it a sec. Here we go. It's a picture of you guys. So what we see on the right hand side is a defragmented disk, specifically paying attention to the blue line there. All the documents that's of similar kind are on the same place. So on the left is a fragmented hard drive. Each of those blocks, you can think of it as a sector, and those slices, it looks like a slice of pizza or a slice of pie, is a cluster of sectors. It's a whole cluster. It's obviously not up to scale. In reality, this could be thousands, if not millions of clusters and sectors. So this is just spitballing, just to give you guys an idea. Now, I do want to point out that what we are discussing here is not applicable to solid-state drives. Solid-state hard drives do not have movable parts. It's a solid circuit board. Everything is where it is, and the computer will know instantly where something is. It's very, very quick. So what we are explaining here is strictly only applicable to, I suppose you can call these mechanical drives. Let's just say the old hard drives that's got a movable spindle inside. You guys have probably heard these drives, spin up when you start your computer. Maybe if you've got an external hard drive that's one of these old hard drives and you plug it in, you can actually start hearing it spin up and build up some revolutions per minute. How many revolutions per minute? I cannot exactly tell you because it varies from hard drive to hard drive, from brand to brand, and from size to size. The average revolutions per minute from what I've seen is about 7,200 revolutions per minute. There are hard drives that are as slow as 4,500, but that's the older hard drives. And then there's hard drives that go 10, 15, 20 and up, revolutions per minute. Now, more revolutions per minute you would think means it can find information quicker. In theory, yes, but what you also have to keep in mind is the newer the hard drives become, not only do they become faster, but they become bigger. So in the old days, you might have had a 500 gig hard drive of 7,200 revolutions per minute. Now suddenly you've got a 2 terabyte. You think, wow, but that 2 terabyte now runs at a much faster speed. You just keep up to pace, so you're gonna have to increase the revolutions per minute. Otherwise, it's gonna take too long to find the information it's looking for on that hard drive. It has to do more revolutions per minute to find information, which brings us to our topic here. If you look at the picture there on the left of the fragmented hard drive, if you have data all over the hard drive, it's still there, but your hard drive has to do more revolutions per minute to find the information it's looking for. It is clustered. It is all over the place. So it's basically all over the place. So it's going to take a lot longer to find what it's looking for versus if you go look on the right hand side, it's going to do way less revolutions per minute to actually find the information. So I think let's give you guys another picture. So let me just get this out of the way. And here's another picture. Pretty much the same story. So on the left, we've got a fragmented hard drive. Messy, messy, messy. Unorganized. And on the right hand side, you can see the information is organized. Less revolutions per minute to find the information it's looking for, giving you an overall faster feeling. The whole PC is going to respond quicker. You might have noticed that sometimes when you buy yourself a PC, and I'm not talking about a high performance PC even, this could just be any computer. In the beginning, they're all fast. You just installed Windows or it came with Windows preloaded. It's fast. You install some programs, some games, do some work on it, and it starts slowing down a little bit. And as time progresses, the machine gets slower, slower, and slower. Now, yes, this can be for many reasons. It could potentially be malware. It could potentially be a failing hard drive. It can be this. It can be that. You've got maybe a lot of stuff booting up with Windows in the background. But one of many things it could actually be is your hard drive is fragmented. It's messy. Now, what I would also like to point out here, which is actually very important, it's probably not part of the course, but I feel I should mention to you guys. This is something we used to do on computers, once in 6 months, once in 2 years. Whenever the average person would feel the computer would get too slow, we would go and do this. We would normally start this whole procedure, when we're about to go to bed or when you're about to leave the office, because it used to take hours and hours, sometimes half a day. If you're wondering where you find this, by the way, you go into your computer. I think it's called this PC. You right click on a hard drive you suspect is fragmented. You go to Properties. Once you click on Properties, you'll find a tab that it says Tools. There you'll find the disk optimization one. You'll also find check disk there, which actually checks for errors and corruptions, which is not a topic in this specific module, but you'll find that there as well. Now, up until Windows 8.1, we had to actually go and do that manually. You can still do that on Windows 10 and 11 manually if you so desire, but it's not necessary. Since Windows 10 got released many moons ago, Windows 10 and Windows 11 actually does defragmentation automatically once a week. So because it does it automatically and because it's so frequently, it goes so quick. If you're going to do it so frequently, it's going to happen very quickly. And it normally tends to do this when your PC is just idling there, doing nothing. So yeah, then you don't even notice. Maybe you went to go make a quick cup of coffee. Maybe you went to the restroom, and while you were away from the machine, it actually did this for you. How nice is that? Now, speaking about right-clicking on a hard drive and clicking on properties, something else you guys will actually find in that same place that brings us to our next topic here, which is what are disk quotas? If you were to go into this PC or whatever it's called these days, and you were to go and right-click on your hard drive there, go to properties, you'll find there's another tab there, not the one tools, another tab that's called quotas. There, it will allow you to go and configure, well, you've probably guessed it, a quota. What is a quota, you might wonder? It allows you to basically set a limit as to how much space a specific user would have on that specific hard drive. So this PC could have more than one hard drive, it can have one, it doesn't matter. You choose the hard drive where this is going to be applicable, you go make a quota, and you can apply this quota to a certain user on that computer. Now, if I have to be perfectly honest, I don't think you're ever going to use this because, let's face it, everyone these days has their own computer and you're almost never going to see someone sharing a machine. So if someone is sharing a machine of someone else, 2 or more people, and you don't want them to go and use too much space, maybe there's a terabyte hard drive with 3 people sharing this machine, maybe they work in shift, and you don't want someone to go and hog all the space. You can maybe go and split it 3 ways. 333 gigs for each of those 3 people. So this is basically effectively going to go and limit how much space each of these people can go and use, so that one person doesn't go and hog all the space for their movies and pictures and games and whatever else they're going to be putting on there. That is a quota. Now, in case you're wondering what this looks like, so if you were to go and click on it, this is actually what it's going to look like. It's a picture. So you can see there's a tools tab there as well, mind you. So I actually should have done this earlier. So if you were to go and right click on a hard drive and you click on properties, this is more or less what you guys can expect to see. You can see there's a tools tab way at the top on the left. That's the one we spoke of earlier. The one we're talking about now is a quota. Now, we actually still do use quotas very extensively in real life, just not on the user's computer itself. This is something we do on the file servers. So if you find yourself in a situation where your organization or your client has a file server, which is better known as a DFS server, if you go there, we don't just want any willy-nilly to go and put in whatever they want onto the file server because some people might abuse the space. So you can go and create what we call quotas on the file server, effectively limiting how much someone can actually go and put on there. So maybe, and this is actually how we do it for most companies, we will go and create a folder for every person that's going to actually be accessing this file server. It might be all the employees. That folder will have the employee's name on it, and he or she can only access their own folder. Along with the administrator, they can obviously access everybody for good reason. And in that folder, you've got a limit as to how much you can put in there. You can go and limit it to 5 gigs, 10 gigs, 100 gigs. That decision is going to remain of the IT people, obviously. Alright, folks, and this brings us to the last main section of this module, which is going to be the quickest one of the lot. The first one was the biggest and the longest. The middle one was, well, middle. And the last one is the quickest and the shortest because it actually literally just has one quick small topic in it. And that last section is managing storage spaces. So we use storage spaces to add physical disks, physical hard drives of any type and any size to a storage pool, and then create highly available virtual disks from the storage pool. So what's going to happen, and I'm going to try and draw this to the best of my ability, so excuse me for my drawings. So what I've got here is, well, let me draw 3 little square little blocks here for you guys. I want you to imagine these 3 blocks as 3 physical hard drives, something you can physically touch with your hands. The size of these hard drives doesn't matter. We can even on purposely make them different sizes. So we can make them totally different sizes. The one on the left is maybe 100 gigs. The one in the middle is a 250 gigs. and the one on the right is a 500 gigs. Totally random sizes. Now we are going to take, you normally need 2 or more hard drives to actually pull this off. We're going to take these 3 or more hard drives and we're going to combine them together into something called a storage pool. Now this storage pool, the size of it is equal to the amount of all of your hard drives. So you can obviously go and remove hard drives, you can go and add hard drives as long as you don't go less than 2 in most cases. So if you go and take 500 plus 250 plus 100, that's about roughly 850 gigs. So that's the size of my storage pool. Now using this storage pool, I can go and divide it into something called storage spaces. You can think of this storage pool as a normal hard drive if you were to go into disk management, which we spoke of earlier in this module. And if you have a normal hard drive, you can go and do something called partitioning, something you guys might remember from earlier. That's like taking a pizza or a pie and slicing it into slices. Is there suddenly more pie or more pizza when you slice it into pieces? No, you've simply sliced it into pieces. The storage pool is like that hard drive we had earlier. And just like the hard drive earlier, which we could go and partition, you can take that storage pool and you can go and, well, I suppose you can call it partitioning, but we call it making storage spaces. You can make these storage spaces any size you want. You can make as many as you want, as long as you do not exceed the total amount of space available in the storage pool, which in this case is now 850 gigs. Eventually, once you've got your storage spaces and all of that set up, you're ultimately going to end up with what is known as virtual disks. That is our end goal here. You want to go and create virtual disks. Now, believe it or not, that's the only thing that's really mentioned in this course about storage spaces and virtual disks and storage pools and all that, which I find surprising because this is actually quite extensively used in a lot of companies, and we used to use this quite extensively. But I suppose that's all you need to know for the exam if that's all they cover in this course, because the exam is normally based on what's in the course, and this is what's in the course. So I suppose that's all they're going to ask you guys about that. Anyway, folks, if you have any questions about what was discussed in this module, please drop a comment down below with your question. If you're still watching at this point, if you're crazy enough to watch this in one go, let me know if you watched this whole video in one sitting. I think a lot of people will go and pause and then save the video, or add it to a playlist of some kind, and just come back to it later and just maybe use those little, what do you call it, those little shortcut links I put for you guys in the video description down below. Those timestamps. I couldn't remember the dang name right now. It was timestamps. So yeah, if you guys learned something, drop a comment down below. If you have questions, drop it down below. If you're still watching at this point in time, drop a comment down below. Heck, and if you've liked the video, give a like. And if you'd like to know when Module 7 comes out or one of the other videos for one of the other courses, of course, remember to also subscribe. Lastly, folks, like usual, special thank you to the sponsors of this channel, PayPal sponsors, Patreon sponsors. If you yourself would like to sponsor the channel so I can continue making more free content like this, you can find all of that information in the video description down below. Thanks, guys. See you on Module 7.
If you love me, let me know. If you don't, then let me